In this video, I'd like to present a method to generate synthetic data of segmentation masks for defects and quality inspection. I'll first give you some context about the task of semantic segmentation and why we could use extra data. Then, I'll go through a simple demo that uses my Blender add-on. We'll use the output of this demo to train a neural network. Finally, I'll showcase some of my more complex models. If you want to try out my add-on yourself or train a segmentation neural network, you can find the code in the GitHub link in the description. In computer vision, the goal of semantic segmentation is to assign a label to each pixel of an image. For example, the picture on the left shows Ricky and Julian, and we would like to segment this picture into 4 classes: background, persons, smokes, and rum and coke. This would result in the following segmentation mask, as seen on the right. There are multiple methods to tackle this problem, but the current state-of-the-art methods employ deep neural networks, such as UNet. Our input here is an RGB image and the output a segmentation mask. More specifically, on the left we see the information captured by the red color channel. Again, we would like to assign a class label to each of the pixels. This would result in the right image. The classes are, for example, represented by integers. You can imagine why soft borders are dangerous here. A value of 3.6 should not represent a bit of smokes and a bit of rum coke. So how do we get from an RGB image to a mask? We are actually going to teach the neural net how to behave. How do we teach it? We're going to show it data. We're going to show it tons of images of persons, smokes, and rum and coke, and corresponding segmentation masks. Eventually, the neural network should know what the background is, what persons are, what smokes are, and what rum coke is. However, acquiring high-quality data to train deep neural networks can be an enormous challenge, which brings us to the next question. Why would we want to generate synthetic data? Take, for example, this case of medical image analysis. Tracing a foreground-background mask of persons would not be the hardest case ever to accomplish, but imagine the semantic segmentation of multiple types of malicious cells in X-rays of lungs. Not only would this be a daunting manual task, it also requires the time and energy of a skilled professional. Furthermore, the data might be scarce if we're dealing with a rare disease, and sometimes we don't even have certain samples. Well, this is where Blender fits in. There is a very interesting intersection between CGI and deep learning, and one of the things that lie on this intersection is the generation of synthetic data to train neural nets. On one hand, you have the real-world images, where you have to manually add segmentation masks. On the other hand, given that we can create a pretty good representation of the real-world images with Blender, the masks almost come for free. There are various caveats when creating a synthetic dataset though. For example, you can unknowingly introduce certain synthetic artifacts that the neural net will pick up, which creates a biased model. And all in all, you want to more or less simulate the distribution of the real-world population. This is by no means an easy task, so you will have to pick your battles carefully. The battle I'm picking is with defects. These are fairly easy to recreate in Blender and should be accurate enough. On the left you can see a simple model with 2 balls. The left ball is a real object with paint scratches, and the right ball is the segmentation mask. On the right side, I've downloaded the car model and added some scratches of varying severity. The ground masks are at the bottom. And finally, here is an example of a phone with cracked glass and its corresponding ground truth. I must admit that this is nothing new under the radar. Some scientists have used GTA 5 to create both input and ground truth in order to teach driving AI. There are also some other implementations that use Blender. I leave that for you to Google. So in this part of the video I will show you a quick demo of the add-on. This is by no means the best way how to do it, it's just a possible workflow. In this demo I'll show you how to use my script and how to recreate this simple cube with scratches on it. On the left you can see the realistic render, and on the right you can see a ground truth mask. So let's run Blender from a terminal, that way we can show some more debug information. And then start with a default cube. I'm gonna run this add-on so you can follow along. And then at scripting, I will open my script. and I will run it. And we should have another tab called Annotation. So first of all, you'd want to set it up. So we can choose separate background class. One defect class is okay. We're just gonna have one type of scratches. And so we're gonna generate the components. Okay, that's done. Now we're gonna add some more geometry. Let's add some bevel. Okay, shade smooth. Alright. And then also we would want to turn it 45 degrees around the X. Okay, now we want to go to shading. To shading, we're gonna drive the scratches with an image texture. I'm basically gonna follow along the technique Blender Guru explained in his anvil. So he modeled this anvil and then he made some scratches on it with the paintbrush, and it will also be very useful in this context. So let's give it some UV mapping, and then because of the we ran the setup, this should show defect 0. So let's use that. And basically we're gonna drive a color. You should use alpha because the mask is transparent. It will also help other small steps in the process. So connect this to the base color. Let's go with some shade of blue. Decrease the roughness a bit and then give it a clear coat. Okay, this looks a little bit like paint. What we now have to do is everything that will have an alpha. It will become white, and otherwise it'll stay blue. So we can directly dive into texture painting. Okay, so we have here defect 0, nice. Here also defect 0. Let's just go into another display mode. And then we have to load a brush. So I recreated a brush just like Blender Guru, but with a transparent background. So what you can do right now, you can go to texture, stencil, and here you can see it. So if I would paint over this, it would actually appear on my model. So there it is. There a big scratch. I also want to add some random scratches. Just here, like that. And then also on the other side. You could do this with more finesse, but you know the deal. Okay, that looks good for now. Let's go back to shading and let's add some more things to make it a little bit more realistic. So if you look into this alpha layer, well, you can see that it's black and the scratches are white. So we can actually directly give it to the clear coat roughness. So now the paint should still be have the same. It should be like flat, glossy, but the scratches should have a higher roughness. And we can actually also do this for the roughness of the main object, but we would need to add a color ramp and then drive up the low value. And then finally, let's add a bump. Okay, connect it to the height, connect the normal to the normal, and invert it and drive it down. So now you have a little bit of scratching on the sides. Let's organize this a bit. Let's add a frame. Okay, and let's call this realistic. Now what we can do is we can add new mode switcher. You will have this if you run the generate components. So just plug it in here. What we'll do then is we add another mix RGB. I will use the mask to drive it and then connect it to the ground truth. And let's also add a frame here. Like that. Let's call it ground truth. So we can do now, we can go back to our annotation tab, and now we can go to rendered and we can toggle it. So right now we're toggling between the realistic view and the ground truth. So not much is showing here. That is because we actually need to say, for example, the healthy part is green and the scratches are red. It looks good. This could use a color ramp. Put also in the frame. Change this to constant and then drive this down. And now this should be okay. This should be visible enough. So what we have now is actually we can toggle between realistic material and the ground truth. Let's also do this for the world. So let's plug in environment texture and your favorite HDRI map. So I took this studio, and because it's a node, we can also use it here. So let's add a mode switcher, and as a ground truth for the background, let's change it to full blue. So what you see now, right now, you can get a nice mess like this. To say a little bit more about the mode switcher, this is just really basic. It's actually just a mixture, and I'm driving this factor with an operation. It's doing more behind the scenes, but this was the most elegant way to set it up that I found. Okay. Then actually, yeah, we're pretty much done for now. The camera is also set up, so if you go into the camera mode and you sample the variation, you get different things each time. What you could do, you could also, for example, find the data paths and then change it in the scripting. So if you go here to the operation that drives the run variation, well, here you can put something like, okay, change base color or something like that. Okay, then we can actually run some samples. So first of all, let's dial this down a notch, and then we'll do 10 samples, and we'll select an output folder. Okay, and now we'll generate it, and voila, 10 images have been generated. If we go to our projects folder, output, so 2 maps have been made. So here are samples of the realistic render, and here's the ground truth. Okay, thanks for checking out my video. I will probably make another video with a more complex example soon, and I would also like to make a video with actually using this to train a neural network.